All right, good morning, folks. Happy Monday. I hope everyone is doing well. Good morning. All right, so I'm doing all right. It was definitely, I feel like the weekends get shorter and shorter, but I think that's just part of being an adult, is that all of a sudden it's Friday and then it's Monday again, and you're not quite sure how that happened. How are you? Sad part of adulting, for sure. Yay. All right, well, let's go ahead and get started. I'm gonna go ahead and, ooh, didn't have it pulled up. I'm gonna go ahead and not display everyone's grades on Zoom. That would be a terrible idea. I'm gonna move to the announcements first before I share my screen. All right, so we've made it to the last week, which is crazy because you probably had like one, maybe two exams in your other classes so far, and that's kind of it. But here we are, we're at the end of Math 116, which is college algebra. So a few announcements for this week. Exam 4, the topic list has been posted, and that exam is going to be on Wednesday of this week. Okay, so remember, we're not meeting as a live class on Wednesday, so you'll have that time to kind of study, take your exam, get a little bit of breathing room, because I know this is a hectic week. Your final exam is cumulative. That topic list has also been posted, and that will open on Friday morning and will close at Saturday morning at 9:30. Okay. Um, if you look at the topic list, I would highly recommend making your reference sheet based on this topic list. Okay, if that's not a skill that you sort of started doing already, I would use the topic list to make your study sheet, okay, your reference sheet. So the final exam topic list is posted under logistics just because I didn't know where else to put it, literally. So it's under logistics, and you get a two-sided, double-sided reference sheet for the final exam, okay? Because I know it's cumulative, which means there's a lot of information, so you can use two sheets or two sides of a regular sheet of paper. I did want to clarify one thing though, which is that with the reference sheets, I think I said like it must be handwritten. If you have a tablet, you're welcome to write on it. I think what I was trying to avoid is people just like screenshotting things and cramming them all into a document rather than actually like taking the time to write them out and think about what they needed to know from it versus what they don't need to know. Okay. Yes, so the reference sheet for the exam is going to be two-sided. Okay, week 8. So we are going to be covering 9.4 and the difference quotient today. On Wednesday, we will not meet as a class. You all turned in homework 7 last night. Classwork 15 will be due today by 5 p.m. You have a quiz on Wednesday. It's a quiz due on Wednesday. You have exam 4, you have the final exam, and then you have one last homework, okay? A look ahead. So next week, we're going to be starting Math 104, which is trigonometry. And we'll no longer be using this Canvas shell, but we're going to be using the Math 104. And I believe I posted that one. I published it yesterday. The skeleton is there in that the skeleton should look very similar to what we have for this course. So if you know how to use this Canvas shell, the Math 104 one will not be terribly different, okay? We will have a few more new students joining us. I believe there are like 5, maybe 6 new folks joining us. So please make them feel welcome. And then last but not least, We have Val has a Monday session this week, and she also has a regular Wednesday session. But when she and I spoke on Friday, one of the questions that we talked about was, would it be better for you all if she moved her session from Wednesday to Thursday? Our thinking was that maybe folks would be busy studying for exam 4, they're busy taking exam 4 on Wednesday, maybe it's not the best time for her to have a support session for the final exam. But if she had it on Thursday, then that might give you just a little bit more breathing room to kind of take one exam, put that aside, and then start studying for the final, but also have her there as support. Okay. And then I have office hours. I had office hours today. I split my office hours on Wednesday and Thursday. So we'll have a half an hour on Wednesday, 8:30 to 9, and then a half an hour on Thursday, in case you have any other last minute questions going into that final. Okay. So are there any questions about the announcements for this week so far? Okay. So what we're gonna do then is, where did it go? All right, I'm gonna have us do a quick warm up on Desmos. So I'm gonna send the link. Oh, good question. How much time will you have for the final? I think it'll be 2.5, like same as normal. Most people have been fairly underneath that in terms of how long it takes them. So I'm gonna think about it, but we can do 2.5 or 3. It doesn't actually really matter much on my end. Do you all have a preference? I know sometimes sometimes the final just feels scarier, it's just more time. Okay, cool. Yeah, we'll do 3. I'll make sure to change that. Yay. Okay, so let me put this link in the chat right here. And so this is for just 2 quick slides on Desmos. So I know we've used Desmos before to do some math stuff, but we can also use Desmos to do some other things. So there's 2 slides in here if you click on that. And it will take you to a very short activity just to check in. I see 2 of you have already signed in. That's awesome. Oh, so many. 1, 2, 3, 4, 5, 6. Oh, I can't even count that fast. 9, 10. Perfect. Okay. So the first slide is just like, how are you feeling? Because, I think that at some point in the semester, things get a little tough, and that's totally normal. Or maybe they're going super well for you, and that's super awesome also. And then the second question is about Val's tutoring session. So it's just a quick agree or disagree about what might be better for you and your schedule. Okay. All right, looks like a bunch of us are in. We've got 26 students who've signed in. If you have not done this yet, please go ahead and click on that Desmos link in the chat window. It's just 2 quick slides, one to kind of check in and see how you're doing, and the second one to give some feedback about what might work best in terms of a support session from Val. right, so I'll give you maybe another 30 seconds or so to finish up. And then I'll take a look at that during our break and we'll kind of make a decision from there, okay? While folks are finishing that up, today we're going to be spending most of our time with 9.4, which is a section called partial fractions. Um, what we're going to start off with is a very short lesson on something called the difference quotient. Okay, so those are the two main topics for today. So if you have access to Canvas, if you go ahead and open up the difference quotient blank notes, that's where we're going to start for today. We're not going to go through all of it, but we'll do a little bit of the setup, and we'll kind of talk about how to focus your studying for the exam 4 as well as the final. I know, right? If we were doing statistics, it could be fun to calculate the odds of two random people getting the exact same first question. Yeah. Well, everyone's going to get the same first question because it's the statement of integrity. So I'm going to go with 100%. Alrighty, folks. Thank you to everyone for filling that out. I will go ahead and take a look at that in a little bit. In the meantime, I'm going to go ahead and share my screen so we can take a look at the difference quotient. Okay. All right. So the difference quotient, all right? Here's why I wanted us to take a look at the difference quotient for our class, which is Math 116, okay? So when we get to Math 150, which is, again, is the goal. By the time we get to Math 150 in the spring, the goal is that you all will walk in feeling a little excited and maybe a little nervous, but ultimately hopefully finding yourself really well prepared for the course, okay? So that you've noticed maybe there's some sort of algebraic skills like factoring and things like that, and graphing and knowing what certain pictures look like that I've really been focusing on. And the point of that is that so we can really have a solid foundation going into Math 150. And so in Math 150, we actually learn about slopes of functions, and we spend probably the first 8 to 10 weeks talking about slopes of functions. Okay, that is basically all we do. We look at slope, we look at all different kinds of slope. Okay, so let's start with a few pictures here. Tell me about the slope, whoops, of that. It's a positive slope, exactly. So we have a positive slope here. All right, what about this? Ah, very good. We have a slope of 0. M is positive, M is 0. What about this third case here? What kind of slope do we have in that third picture? Yeah, we have a negative slope. Okay. What about this? What's the slope of that picture? All right, we have one answer that says negative and then 0 and then positive. So are you saying then that this curve has different slopes depending on where you are in the function? Okay. So maybe if we looked at this like this part, if we look at it, is going down, like if I go from left to right. And so this side does actually have a negative slope, okay? But in contrast, this other side, as I read from left to right, has a slope that is positive, okay? And then there's one special point right here, right at that vertex where the slope is 0, okay? So a lot of times when we've been talking about this, about slope, we focused on these ones. It's the same slope all the time, which is kind of nice, but ultimately not nearly as exciting as something like this, where maybe we have instances where the slope is different in different places, okay? What is this function? Yeah, I would agree this slope is positive. What's the name of this function? If we start to think about reviewing for the final, what's the name of this function? Yeah, it is the exponential one. Perfect. And we know that equation is y equals ab to the x, right? Cool. Okay, yeah, and I would agree that this one does have a positive slope in that as I go from left to right, it kind of keeps going up the whole time. But it's not going up by the same amount every time. It's kind of starts off flat and then it goes higher much more quickly, okay? So it's not quite the same as sort of this linear function picture. And so that's what we're going to spend the first 8 to 10 weeks in Calc 1 talking about, is all different kinds of slope. What do we know about them? What are their uses, okay? But I wanted to do one example of something that we are 100% going to see probably in the first week, maybe the second week of Math 150, okay? Now, before I do this example, some of you may have already seen this before. That's totally cool, okay? Some of you might be like, what is she doing? And that's also cool, all right? Now, either way, don't be too excited if you've already seen it before and you know how to do it. And don't be too nervous if you're like, I've never seen this before and I don't know what she's talking about. This example will not be on exam 4 or the final, but I kind of want to show you what we're going towards, okay? Because we're only going to do a small piece of this today, but I want us to see how this fits in. So this question says, use the formal definition of a derivative to find the slope of a function, f of x equals 3x squared minus x plus 4 at any point x. And so what we're going to learn how to do is something like this. The limit as h approaches 0 of f of x plus h minus f of x over h. Okay. And then we're going to take our function. And our function in this case is this. And for the f of x plus h, everywhere I see an x, I'm going to put x plus h. So I'm going to end up with 3x plus h squared minus x plus h plus 4. And this part corresponds to f of x plus h. And that's what I got for my f of x plus h. Then I subtract my f of x, which is 3x squared minus x plus 4. And I got this just from the function that I was given in the equation. And then I put this all over h. And then the limit as h approaches 0, and I'm going to FOIL out the top in that green part. I'll get 3x squared plus 2xh plus h squared minus x minus h plus 4. And all of this is the green. minus my 3x squared minus x plus 4, which is my yellow part, over h. And then the limit as h approaches 0. And I'm going to distribute everything so I can get rid of all the parentheses on the top. And I'll get 3x squared plus 6xh plus 3h squared minus x minus h plus 4. And then I got to remember to distribute. I get minus 3x squared plus x minus 4 all over h. And so I technically still have sort of the part that came from the yellow and the part that came from the green. But at this point, I'm going to see what I can cancel out. And I'll notice that the 3x squareds cancel, my x cancels, and my 4 and negative 4 cancel. And then I want to see what's left. So the limit as h approaches 0 of 6xh plus 3h squared minus h all over h. And oh, check this out. There's the greatest common factor on the top of h. So let me factor that out. H parentheses 6x plus 3h minus 1 over h. And that's really nice because then this top h I can cancel with the bottom h. And that's going to give me the limit as h approaches 0 of 6x plus 3h minus 1. And now everywhere I see an h, I'm going to plug in 0. So I get 6x minus 1. And so this right here is an example of something we will see, again, within that first week or two of Calc 1. And this is definitely going to be on your first exam in Calc 1, okay? Now, I know we're not there yet. So again, I don't want us to freak out about this whole long process. But what I want us to focus on is the green part for today. So the goal for today and for the exam number 4 is to figure out how to write the f of x plus h part. That's it. We're only looking at the green part, okay? So if you got a little nervous looking at this, don't get too nervous. Our focus is going to be on figuring out how to write f of x plus h. Okay? So we're going to work through 4 examples of how to write the f of x plus h part. That's all we're going to do. I will show you one more example at the end, just to make sure, like, if you're curious or you've seen this before, we get a little review on that. But again, the things to study for exam 4 and for the final is this part right here. So I'll put some stars there so we know that that's the part to go back and focus on. Okay. So let's take a look at our first function. We have f of x equals 2x plus 5, okay? So when I want to write f of x plus h, that means everywhere that I see an x, and let's take advantage of the colors while we have them. Everywhere I see an x, I'm going to replace that x with x plus h. So f of x plus h equals, let's see, on the right-hand side, where do I see the x? Right here. So I'm going to replace the pink x with, so I'll keep the 2, but in parentheses, I'm going to replace it with x plus h plus 5. Okay? So everywhere we saw the x, it became an x plus h. Okay. Does this substitution make sense so far? Good question. I never talked about what H is. Let's just kind of go with the idea of substitution for right now. But if you are curious, what you can do is look up this idea of the formal definition of a derivative. And I don't know if I have any good videos on hand, but it should formal definition of the derivative, and they'll tell you what that H stands for, okay? But we will definitely talk about what the H stands for in Math 150. Cool, thanks for your patience. Okay, so as far as just the substitution goes, all we did was change all the places where it was pink to all the places where it was blue. And we want to go ahead and simplify this as much as we can. So I'm going to go ahead and distribute that 2. So I'm going to get 2x plus 2h plus 5. And that is my f of x plus h. And so this would be my answer for number 1. Okay. All right. Now, if we think about question number 2, we can follow the same idea that everywhere I see this x, I have to replace it with an x plus h. So instead of just having one place to put in x, I have 2 places to put the x plus h, okay? And so that means that for my first line here, for number 2, I'm gonna have f of x plus h equals negative parentheses x plus h squared minus parentheses x plus h plus 3. So x plus h, negative x plus h squared minus x plus h. Okay. Questions about the substitution? Okay. So now if we're going to try and simplify this, I see here that I have a minus sign and I have the square, okay? Which one do I do first? Do I square everything first, or do I multiply everything by -1 first? Yeah, got it, folks. You're going to square it first. Okay, so that's going to mean keep that minus sign outside in parentheses. All right, x plus h squared is going to be x squared plus 2xh plus h squared. Is everyone clear where I got that from? X squared plus 2xh plus h squared? Kinda. Okay, so let me just kind of put this off to the side. So if I have x plus h squared, that's the same as saying x plus h times x plus h. And that, if I FOIL it out, is going to be x squared plus xh plus xh plus h squared. And if I combine my like terms, I'll get x squared plus 2xh plus h squared. So if you know the shortcut that Yugi just put up on the chat, you can use that shortcut. But if you're not really sure where that came from, I think showing your thinking over here like this is not a bad plan, okay? Does that clarify where that x squared plus 2xh plus h squared came from? Great, thank you for asking. Okay. So now when I'm trying to simplify this second term here, what should I be super, super careful about? Because I've seen this so many times. Folks are like, well done. What's wrong with that? What's wrong with this person? Why would that person do that? It's easier to critique that other random person. Yeah, exactly. Exactly, right? This minus sign, we better distribute that to both things in there, which means that this is really a minus h, okay? Now we don't want to fall for that same trick. When we finish expanding here, we need to make sure we distribute this minus sign. And so we get negative x squared minus 2xh minus h squared minus x minus h plus 3. Okay, and that is our f of x plus h. All right, I think as you're studying for exam 4 that this is a really good example to kind of study, okay? Places where you might have to plug in that x plus h more than one place, okay? But nothing crazy. We're not doing like x plus h to the third yet. We'll save that for Calc 1. But for right now, I think knowing, okay, if I have a quadratic, where are all the places I have to put it? What are some good shortcuts to remember about how to FOIL things out, okay? That's where we're sort of working. All right, any questions so far on 1 and 2? Well, let's take a look then at 3 and 4. Okay. So how many places do I need to substitute x plus h in question number 3? Yeah, I have to plug it in 2 places, right? Here's one x and here's the other x, okay? Now, let me ask you a question. Is this x totally under the square root? Or is it like half in, half out? It's totally under the square root, right? We've never really seen something like this and like the x is like half in, half out, right? When we have a variable underneath, yeah, when we have a variable underneath, it's totally underneath. Well, guess what that means? I'm asking that. I know that sounds silly for just the x, but that means when you plug in x plus h, that the whole blue thing needs to be underneath the square root. So I want to write it like x plus h, all of that underneath the square root, okay? What we do not want to do is keep the x under there and then just add a plus h on the end. That's not what we're trying to do. Everywhere there's an x, we want to literally, everywhere there's an x, we have to replace it with an x plus h. Yeah, that half in, half out, I think is definitely some sloppiness, right? But conceptually, if we know the whole x is underneath there, that means the whole x plus h also needs to be under the square root, okay? And so even though number 3 might look a little bit more scary because of the square root, this is it. That's our answer. There's not much else we have to do to simplify that one. All right. How many places in question number 4 do I need to substitute an x plus h? Same, exactly, Christina. We've got 1 and we've got 2. So I can start by saying f of x plus h equals, right? And so here's the substitution I'm making. That thing in the blue is going to replace the thing in the pink. Now let me ask you sort of a similar question. Is the x totally underneath the fraction line? Or is it like partially underneath the fraction line? Yeah, right? The x is totally underneath the fraction line, which means when we substitute, the x plus h also needs to go totally under the fraction line, okay? And that actually, even though this one has a fraction and maybe it seems a little bit scarier, that's as far as we can simplify there, okay? Can someone give me an example of what they think maybe my #1 wrong answer that I've encountered from students is? How do you think people might do this the wrong way? That's so perfect. 3 over x, and they're like, I don't know. Somebody said like add an h to the end. So this right here, 3 over x plus h, is probably the #1 wrong answer I see. But let's take a look at the other ideas. Some folks said that maybe 3 over x plus 3 over h. Yeah, I've seen that too. Okay, that is also incorrect. Moving the x to the top. Yeah, I've also seen people, they're like, I don't really like fractions, so maybe I'll just kind of do this and hope for the best, okay? So 3 very good examples of common mistakes, all right? Sometimes it's like, if it seems too easy, like, oh, you just put x plus h in the bottom, that's it. Like, yeah, that is it. That's the concept. The concept here is that we're going to substitute everywhere we see the x with the x plus h, okay? So here are a couple examples, right? Not a couple, a few. 4 examples of thinking about how we substitute in the x plus h everywhere we see the x, okay? This is what I want you to know how to do for Wednesday's exam and for the final on Friday. I want us to be able to substitute everywhere we see the x with an x plus h, and I want to see that you can simplify accurately, meaning we got to be super careful about those signs. So I'm probably going to make sure there are negative signs in there. I want to know that you know how to distribute, okay? And I want to know that we know how to square things. Like, how do we square x plus h, right? Now, speaking of common mistakes, let's go back here for a moment. What do you think the most common mistake is that I see when I have x plus h squared? What do you think students tell me when I write x plus h squared? Yes, Richard in for the win. This is the #1 mistake. People are like, I know how to square. I'm thinking too quickly, just x squared plus h squared. Okay? But that's not how it works. Okay? That is so, so sad. So do not do that. I'm putting it there in the red so we can see it as like, let's not fall for that. We're better than that. Okay, we know we need to FOIL. We just have to connect those things in our brain that help us remember we need to FOIL. All right, so let's go ahead and let's actually do question number 6, okay? So for question number 6, I'm going to show you sort of how, like, what we use all that f of x plus h stuff for. All right, so when we had f of x plus h from earlier, we said that was negative h squared minus 2xh minus h squared minus x minus h plus 3, okay? Now, as an extension of this, sort of getting closer to what we're going to do in Math 150, there is something called the difference quotient. And the difference quotient is just this part, f of x plus h minus f of x. That's a difference, right? We're subtracting. The difference quotient, because I'm dividing. That's where the name comes from. The difference of the numerators, and then there's a quotient because I'm dividing, so we call it the difference quotient. And so if you know how to do the f of x plus h, what that gives you is the green part that we saw way back in that first example. So negative x squared minus 2xh minus h squared minus x minus h plus 3. Whew, that's a mouthful. Minus f of x, which is going to be just your original function. Negative x squared minus x plus 3 all over h. Okay. All right. Now I can get rid of the parentheses in the first part. And what do I need to be careful about as I get rid of the parentheses in the second part? The signs, yes. So distribute, distribute, distribute. So plus x squared plus x minus 3 all over h. So let's see what we can cancel out. X squareds go away, x's go away, and the 3's go away. What am I left with? Negative 2xh minus h squared minus h all over h. Now, here's a really helpful thing about this part is at this point, yeah, it is. Yeah, because we're talking about slope. At this point, the numerator should have a greatest common factor of h. So I can factor out an h. What am I left with inside the parentheses if I factor out the h on the top? Perfect. Ah, so close. Yes, now perfect. Negative 2x x minus h minus 1, right? We got to make sure there's a placeholder for that h. Now we can cancel out those h's, and negative 2x minus h minus 1 is our answer for question number 6. Okay. So I know I'm kind of throwing this at you like on the very last day of class, right? So like I said earlier, the part that's important is questions like 1, 2, 3, 4, okay? As you're studying, you want to go back and make sure you really, really know how to do this part, f of x plus h, okay? This extra piece right here, I would consider like, oh, I don't know, a bonus level or like a challenge level problem, okay? So if you're like, yeah, I'm studying for the final, I feel pretty good about everything, why not practice a couple of these? And there's a few practice problems in here for you to try, okay? But if you're studying for the final and you're like, man, I have so many things going on this week and really I'm just kind of stressed out and I just want to make sure I don't bomb the final, then where you really want to focus your studying is on these 4 problems. Okay, specifically things that kind of look like question number 2, where I get a chance to make sure we know how to catch our signs, we know how to FOIL things out, we know how to distribute properly and thoroughly, okay? So definitely think about number 2 and questions like that as you study for the exam. Okay, Isis, we don't want to replace h with 0 like I did in the first question in the beginning of class. Yeah. So there's sort of, we're splitting hairs a little bit here, but if we think about just the difference quotient, there's no limit as h approaches 0 in the front. Okay, so the pure difference quotient does not have the limit part in the front. As soon as someone changes the directions and says, use the formal definition of the derivative, then you take this limit of your difference quotient. Okay. Yeah, that's the big difference. If you want to replace h with 0 and like go that extra distance, that's also fine too, okay? But as you're studying for Wednesday and for Friday, again, like this is to give you context of the bigger picture where we're headed, but really what we're focusing on is how do we substitute, how do we FOIL, how do we distribute, all of that stuff, okay? All right, so I am going to